Hello and welcome. This is going to be a lesson on angle measure. This will be corresponding to section 1.4, and then we're going to just say it's part A because we'll split this into two parts today. So the first part is identifying angles, sides, vertices within some geometric shapes. How can I utilize a protractor to both measure and sketch angles accurately, as well as how can I categorize angles based upon their measures? And then lastly, we're going to apply the angle addition, not segment addition, property, or postulate if you want to call it that. So the first thing we're going to do is talk about what is an angle and what is a ray. So again, because these are vocab, we're going to highlight those in green, and then we're going to talk about each. So what is a ray? A ray in geometry is a portion of a straight line. So it's just part of a straight line that starts at a particular point. We call it an end point, even though I like to call it a starting point because it starts and then goes forever the other direction. But it extends indefinitely in one direction, but it has a clear end point, or what I like to call a starting point. Rays are often represented with an arrow to indicate the direction in which they extend infinitely. So a good sketch here would be, hey, we have a dot right here. That's kind of my end point, or like I call it a starting point. And then it goes on forever like this way. And then we'll put another point on there just so we can give it a name. So in this case, let's call this M and O. In this case, we're going to name this ray MO. And the way we will actually write it is MO with a line segment, but with just one single arrow. Now it is important that M has to be first. So whatever, let me highlight this, whatever was here first has to be there first as a letter. So if O was swapped with this, I would have to start with O. So this is ray MO because it has to always start with this starting point, or what we call an end point. We kind of call it endpoint because it comes from forever here and then just stops. But I like to think of it the other way, where it starts here and goes forever the other way. But that's my personal preference. So that is a ray. And we were going to talk about an angle. An angle in geometry is formed by two of these rays or line segments. I believe what we're going to focus on is two rays, but it could be line segments as well. But we usually have two rays that share a common endpoint. So they have the same endpoint, and we're going to call this the vertex. So I would highlight this vertex, and this is basically that common endpoint. So let's do a quick sketch. So we're going to have this endpoint, or like I call it, a starting point, and we're going to go away with a ray and put a lovely dot with it. And let's name this B and then A. And then we're going to have another one, a ray coming off that same endpoint right here, going this direction, and put another dot, which we can say that's C. So this would be A, B, C. Now that is what an angle is. It's this whole opening. How much does this open? We're going to put a 1 here to call that angle 1. So there are multiple ways to name this. We could say that this is angle 1. I like to write it as angle 1. This is the symbol. We use kind of a flat greater than, or this is a less than kind of looking symbol, but it has a flatness to it on the bottom, and then it opens up like an angle. So it's different than less thans or greater thans because it has that flat bottom, which means angle. So it's angle 1. Or we could do angle A, B, and then C. Notice that we are going to, in fact, have in the middle of this has to be that vertex because the vertex is in the middle. So it has to go in order, the way we walk it, A, B, then C. Or we could do it the other way, C, B, then A. But we can't start with B. B has to be in the middle because it's in the middle of the angle. That's where that vertex is. Where do they share? So let me move this over a little bit, or I'll just write it here. And then angle C, B, and then A. Again, we could write that as angle A, B, C, or angle C, B, A. So I like to do the symbol way here. So that is my personal preference. Remember, if we do that, we highlight those in those colors, that pink or reddish color, just to have that how we say it or how we write it. So again, this is how we would write it, or sorry, how we would say it. This is how we would write it. So above is how we would say all of those, and then below would be how we should write it as symbols. So that's how I would expect you to write it. I always like to do angle 1 if it has the availability, but a lot of times you can't do that. So let's go ahead and do example 1 and example 2. So I'm going to move this up here. And again, we are going to be highlighting these in blue because they're examples. Blue you highlight as the examples. So let's go ahead and walk through this. So using this figure to complete each part. So we have TQS, we have TQR, we have SQR, like all of those things, angle 1, angle 2. So we're going to name the sides of angle 2. So I'm going to go ahead and just use a highlighter. Well, let's use a marker. Let's say angle 2. And remember, angle 2 is formed by this and this. That is where angle 2 is. It's right here. So the two sides of this is QR, or RQR, and QS. Again, we're going to name them as rays. They have to go this direction. So it starts at this point here, Q. So we have to have Q first, and then R. And then we have to have Q, then S. There's no way other than there's no other way to do it. It has to start with Q. I'm not sure if Alex, your homework, will accept this as a segment symbol, but I think they just only have the ray symbol. So we are going to stick with rays because that's usually how we define them. So we're going to write two other names for angle 1. So let me do this in red here. So again, angle 1 would be on this side. So angle 1 is right here. In this case, we have to walk this. So we start with T and then Q. Again, Q is the vertex, so it has to be in the middle. So T. So we're going to do angle TQ and then R. And then lastly, angle with the backwards way of RQ, then T. So it just kind of walks backwards. It's RQ, T, or TQ and R. Like the letters are in the same order, but just backwards right here. And that's how we would name that. And then what is the vertex of SQR? And one thing to note is the vertex is always going to be in the middle, so we don't even have to look at the picture. It has to be in the middle, but if you think about S, then Q, then R, well, it has to be this middle one, which is Q here. So that would be that vertex. So let's go ahead and use a protractor to do these next ones. So on Alex, we're going to be using this symbol here. That's our protractor symbol. So we'd have to make sure we click this button, and then this protractor would pop up. So what we're going to do is, do you see how that we have this middle part right here? There shouldn't be an X there. I just couldn't get rid of that. But we're going to have this here, and we're actually going to put that right in the middle of this, on that vertex. So when we measure both of these angles, we have to start by moving this right on top of that vertex. Now, once you click that, you'll be able to turn this. And notice how we have 0 to 180. Now, in this case, we have 0 over here. So we want to put this line on 0 here, or this ray on 0. So the vertex, you click, and then you have the ray pointing to 0 here. And then we're going to move up all of these degrees to wherever this is here. So if I measure this a little bit more accurately, sort of like that, it goes up by 10s, and in the middle it's by 5s. So it goes up here to 120, and then in the middle of 120, 130 is 125. So these will always be to the nearest 5 degrees, just for simplicity's sake. So this angle right here is going to be that 125 degrees. 125 degrees here. So now what we're going to do is try the other one, which I'm going to move this over here. Again, you would click this right there. We would put that on the vertex. And notice how we have this right here pointing over here. We want to make sure that this is at 0. So we're going to have to rotate all of that till we get that to 0. So again, you click the vertex and then you rotate it until this one of the rays is pointing at 0. If I put it over here, it won't be able to measure. It'll be measuring over here. So it kind of has to be this weird upside down. So now starting from here to here, how far is it this way? So if you look at that, it's all the way up to, it looks like almost 180, but I think it's more in the middle. So let me be a little bit more accurate here on this, just so we have that. So that's about right there. So I'm going to say that's 170, or sorry, 75. I think it's going to go right there. So this is about 75 degrees. Again, we're not going to do like 77 degrees. We're going to go to the nearest 5 degrees here.